All right, let's roll. Hey everyone, welcome to this year's OpenXdata Summit, and good morning. And today I want to talk to you about a shift that is going to, in my opinion, redefine data platforms over the next decade. I spent been working on data platforms from 2016, incidentally, to 2026. So I'm really looking forward to the next decade here. So spent the last decade, like I mentioned, building lakehouses, open formats, file formats, table formats, query engines, pipelines, streaming systems, but all for human users, right? And analysts, engineers, data scientists, applications with fairly predictable access patterns. But the next major user of the data platform, surprise, surprise, is not human, right? It's going to be autonomous software. This sounds like a small change, but it's not. It changes the workload, it changes the failure mode, it changes the cost model, it changes a lot of things. So let me maybe get into it by briefly explaining why I care about this. Right, I spent most of my career working on open data systems, writing from data ingestion to incremental processing to ETL to table formats, query engines, Lakehouse infrastructure. I helped create, along with my team at Uber, the first data lakehouse, and we branded it production scale way before the term was even coined later on in the market. We solved some very forward-looking problems that power to this day very large data lakehouses at like Amazon or JD or Walmart and thousands of other companies. At Onehouse, I founded Onehouse 4 years ago or change. We're trying to build beyond that, like a single project. We built Onehouse as the most open flexible data platform that supports any table format, data format, any engine, any catalog, any cloud. We are the only platform in the market that can actually say this. And our engines can meaningfully cut your cloud bills while keeping data open, right? But I'm not here to give you a pitch. So I'm just trying to tell you that this talk is from a perspective of somebody who's not looking at AI and the shift from the outside. It's from the perspective of somebody who spent a lot of time building these data substrate or these various data systems. And I see what these new AI agents are going to do to the data platform, and the opportunities and the challenges within that, right? So the very simple reason is the data platform that we built over the last decade or so is about to break. Not because we built it wrong, not because it's bad, right? The Lakehouse, the warehouse, the query engines, the pipeline systems, all of it is still very crucial. It's going to remain critical to thousands and thousands of companies out there. It's going to break because the user of the platform is changing, right? Most of our assumptions in the current stack are human assumptions. Somebody asks a question, waits for an answer, interprets it, then decides what to do next, right? We kind of rely on the patience of human beings here. That assumption is changing. The human to machine movement is growing way faster than most data platforms are prepared for. And over the last 2 years, we've seen that, right? A massive shift in terms of the amount of queries that are being generated to these systems from software versus like people typing these into a white SQL text box, right? So AI initially showed up as copilots, chat interfaces, right? Is meaning very meaningful. It still looked human centric, right? It was still a text box where you type something in and then the model tells you something, right? But now we are moving into agents, right? Full steam ahead this year, and systems that these systems plan, call tools being like any database or API or anything that you do, write code, inspect results. They run in a loop until they accomplish a goal. So that's actually a popular social post from our VP of product, Kyle Weller, where he's referencing how the Matrix, the movie, warned us about agents 25 years ago. And, you know, the uncomfortable truth is they're going to do some bad things to your data systems and data infrastructure, not because they're malicious, but because the access patterns they create are fundamentally different. Right? So, by the way, if you like more of that content, you should catch a talk on Spark and performance. I think you'll find a lot more sharp points like this there. So, we need to remind ourselves what the data stack was originally designed for, right? So it was designed for humans, as in we build dashboards so we can look at what's changed. It's largely static, right? Notebooks or interactive exploration environments where you can write code and explore data, still again kind of static, right? um, And batch pipelines are built around some scheduled, human timelines where you can operate the pipeline, things like that. Interactive query engines to ad hoc questions, right? See, like for all of these things, if you imagine the user to be a machine, then it changes a lot of things, right? Most analytical engines, for example, they can bottleneck with mere hundreds of QPS. So the whole stack kind of right now assumes that the user is relatively slow, bounded, and very intentional about what they're doing. All those three assumptions are gone. Right? Before, the loop was pretty simple. A human formulated a question, submitted a query, waited for results, interpreted the output, decided what to do next. Now that loop is slow, right? I mean, it has natural limits. We, like humans, we sleep, we get bored, we go browse something, we take breaks. But if you want to have agents and machines operating continuously on the data, they don't wait, they don't have to sleep. They think for themselves, right? You're now you have like two parallel brains, and decide what to do. You only know about what they did after the fact, right? So the question no longer is, can my data platform answer more queries, right? That is not the question. The question is, can my data platform, how can it adapt and survive when the primary consumer is software, not a human, right? That is why if you simply treat AI agents as just faster humans, that's like a pretty dangerous mistake, because like I said, they run continuously, right? You can't schedule some warehouse maintenance over a weekend anymore because nobody's in the office, right? You can do things like that. They generate queries autonomously. Nobody's sitting there writing SQL in advance. The agent, based on a human language query, is going to decide, oh, for this I need to generate these kinds of SQL queries against these systems, right? And how to ask for it. They act on results immediately. There may be like no human review step in between too, right? I mean, this is the whole point of having AI agents, is to not have humans be the bottleneck in between, right? So they can scale unpredictably, right? Like you've already seen this. If you're using Claude, Codex, or any of these tools, the one agent can become 10 because it'll do a lot of sub agents, like do some scatter gather, these kinds of things. So a workflow can trigger a whole cascade of queries and tool calls that no capacity planner anticipated, right? This is not just some workload increase, it's also a workload change because now they can kind of ask arbitrary things, right? So humans ask questions, but agents are trying to operate a system. That is at least the north star for where these agentic platforms are headed. So this means the data platform is no longer just supporting like analysis or data science or like something like that. It's becoming a part of the runtime for autonomous software. And if your data platform is slow, stale, fragmented, the agent is not just inconvenience like a human, right? I mean, the query warehouse queries are slow, somebody complains, right? It's not that. It's actually can act on the wrong world, and the wrong kind of context, right? So that brings us actually now to the central word in this whole discussion: context, right? Context and data are the hottest words around right now, given where the foundation models are. So agents live or die by context, right? An agent without context is just not like an optional thing. It's actually dangerous, right? You're granting an agent to do things and at machine speed, and these wrong decisions can compound very quickly. I will not name them, but like we've seen this year how a very popular major cloud provider has had several outages attributed to kind of like lots of autonomous decisions being made by AI agents, right? So this is like definitely the direction that we need to go, but it is, you need to get a lot of things right. So when I say context, I mean the data an agent needs to reason about the world. This can include facts, history, what happened before, what decisions were made, what outcomes occurred, current state, past state, relationships, everything, right? So many AI projects today fail because of AI ready, like data, right? AI readiness is a data problem. It's not a can I get a better model problem alone. Of course, you need a better model. That is like we're making phenomenal progress there. But your data is poor, then the model is no longer the bottleneck, right? So let's make this term concrete, right? What does context mean for data systems? Context is fresh, joinable, cheap to query runtime data for AI systems, right? This is very practical, intentionally very practical definition. Basically, you want a bunch of data about various things that I talked about, which are in this kind of like it's very fresh, it's pumping in all the time. You can correlate them very cheaply, right? If your data is stale, then your agent can be wrong completely. If your joins are slow, then your agent is going to lag, right? That response that you get from your inference is going to take a while. If your pipelines break, right, your agent is acting on a past and can hallucinate and bad things can happen, right? So this is no longer about analytics. We are not building data sets so that humans can look at the data, right? Building and serving this context, I think, is a new workload that is going to now sit on top of data platforms. And the problem is this context is today like super fragmented in any enterprise, right? Like how data generally is. Um, for humans, maybe that was manageable. We can ask around, right? You can be like, oh, where is the data? Oh, it's in low. I'll go ask this person in Slack. Oh, check the warehouse. So maybe that thing has it, this thing has it. So agents cannot operate like that, right? You need to tell it precisely what data is where, what it means, all of that. And you have to connect the dots for the agent for you to be able to have the agent operate autonomously. So the agent cannot afford slow manual stitching. It needs context while it's deciding. Right. But the thing is, history of database design means you may have like many different databases, data warehouses, any different data storage systems in your company, right? OLTP systems are great for point lookups. OLAP systems are great for aggregations and scans. Data lakes are cheap, durable storage that you can do a lot of transformations and ETL on. Vector databases recently emerged to do these kinds of like similarity searches during inference time. So but they're all optimizing for a specific workload. But agents, they don't really understand this, right? Like they don't respect these system specializations. They're gonna, if you tell them, they think this particular system has this piece of data, it's gonna try to go generate a query against it. So agents can generate all query shapes at once on against this context data that can live in everywhere. It can generate narrow queries for point lookups, like knowing what is the state of this order, right? Generate wide queries, scans and aggregations, trying to understand more deeply where the patterns are, things like that. They can do search queries for semantic relevance. They can do join heavy queries for relationship traversal across entities. They need all of this at once. If you block that loop, then your inference is going to be slow. If you're self-hosting your model, you're going to waste a bunch of GPU, very expensive resources. So the thing is, not a single system so far has been designed to handle all of these access patterns simultaneously, right? But agents, kind of the way they operate right now, they don't really care. They just need the data when they need it, and they will decide at runtime what kind of data they need. Right? This mismatch between what the agents demand and what our infrastructure was built to deliver is the underlying tension that we need to solve. And if this sounds familiar, it is kind of pattern you have seen before. This, what they're doing is not really very new, right? It's basically what federated querying was. So agents have these notions of tools, meaning like a database, a Postgres is a tool, Snowflake or a data via Onehouse, Databricks. All of these Lakehouse warehouses are tools that have data. They make requests across different, all of these like data sources. They stitch the results together, then making decisions on top. This is basically federated querying. Systems like Presto, Trino, like all these query engines have had multiples of connectors. If we've tried this before, it was slow, unreliable at best, and it did not scale, right? Most companies end up not doing this at even moderate scale, because you run a SQL query, it will hit like two microservices, a OLTP database and a OLAP database. It's very hard to reason about performance or any kind of like operational characteristics on these systems. I It's kind of worse now with agents, because of the agents can do many things, right? And then they can decide what to do. face this personally every day. I have all of our company systems connected to, like, Cloud and all these tools, and every morning I ask it to brief something for me and it times out every morning, right? So I should be able to kind of get all the context of my company in a single place without worrying about rate limits, API rate limits, and things like that. Be able to reliably get, let's say, a report or a AI brief every morning, right? So this is basically where we are. And this pattern, like I said, never worked. I don't think it'll work now either, right? And then it's any slow tool will add a lot of cost to your system. So what actually happens now? Take one step further. Let's say, okay, I don't let's see, tell me what actually happens, right? So what actually happens if you let your agents loose on any operational system that you find or any database you find is, it can bypass the data platform, hit operational databases directly, create spikes on production databases that were never designed for this kind of autonomous query generation. Take any OLTP or RDBMS and try to mix scans and kind of point lookups, it won't scale well, right? On the flip side, it can also query warehouses very unpredictably. These access patterns are not ones that query planners expect, right? And cost become harder to bound because it'll scan. If you ask for a single record, it'll scan the entire warehouse, right? So I mean, vendors could like market this as AI explosion, but it's like extremely inefficient, and it'll like really balloon your cost if you just let a AI agent loose on your uh, warehouse without supervision. So they can stitch APIs dynamically, and every API has a rate limit, right? So this will create invisible dependencies. What if this API times out? What do I do? Right? You need to hint the agent on, like, you need to really like how handle cascading failure modes in all of these things. So the result is kind of predictable. You cost explosions because it's unbounded query cost with no circuit breakers here. You lose control over how data is accessed, how often it's accessed, and what decision was being made. So if you want like reliable AI agents, you need to make sure that the context can be served at very large scale without kind of frictions like this. So the bottleneck isn't like compute, right? I mean, it's not like we need a bigger compute engine or something. We spent a decade scaling compute. We made Spark and warehouses and all Flink and all these things faster. We made warehouses faster. We built better query engines. We optimized storage formats. We've scaled cluster, auto scaling, all of that. But for agents, the compute is not the constraint anymore. The bottleneck is access to scalable context, getting the right information into the model's context window at the right moment, right? So that organizing your data and like everything around that is going to be the fundamental challenge that we're going to solve for the foreseeable future, I think. So can the agent reach the data it needs? Can it get that context fast enough to act? Is the context coherent, or is it scattered with unified view? These are the core infrastructure questions, and this is where the old model is kind of breaking, right? If you like so far, if you just summarize what we've looked at so far, the traditional systems worked because the workloads are predictable to large degree, right? You know what queries a user would run, what tables to build. You go ask your data analyst or your data scientist, hey, what do you need? Or you need to model this, I'll ingest this data for you in this way, right? So that's not true anymore, right? Agents break that model. They generate these queries dynamically. They can do so. You have to watch what they actually do, and then combine those access patterns and back that into the kind of pipelines and the tables that you will build. So you cannot pre-compute everything that an agent might need. You can do some extent, but definitely not a good vast majority of it. So the context has to be built and served on demand, and this creates, I think, the points out the missing capability that we have, right? The lake house or the data lake, whatever you choose to call it by, is the right foundation. Pretty much every Fortune 500 company or any like large and small, like there's thousands of companies have those systems, right? But it cannot serve context at agent speed yet, right? And agents kind of need a serving layer that needs this context fresh, consistent, and cheap without copying everything into another system. I mean, you can always do that, but we always end up regretting that too, right? So you need low latency because context is needed when the agent is deciding, not minutes later. This is the difference between a human and a machine. They need high concurrency because, like I said, one workflow can turn into thousands of autonomous queries. You need to handle mixes access patterns, like what we've kind of have a stock trading agent who's doing both, is trying to understand Nvidia performance by looking at a narrow query for last 200 trades, as well as doing a scan and aggregate over 6 months or something to see how the semiconductor industry performed, right? So you need to be able to do this kind of mixed access patterns on right on top of the lakehouse, right? And you need consistent data freshness into the lakehouse. Like I mentioned, this becomes extremely key now in this new world because agents cannot afford to act on stale data. So this is where the lakehouse has to evolve. We already centralized the data into lakehouse, but every pipeline, every ingestion flow, every transformation increasingly ends there. Data pipelines are an area that I've been directly working with on. Some of the lakehouse tech out there offers unmatched transformation efficiency already, right? It's a great place for you to store and cook your context and build your context, if you will, right? And you cannot again like build this context by stitching many systems together. Like we see, federated querying has never really worked at model scale. So the lakehouse has to evolve and become the system that serves the context. From a system that simply stores the data, system of record, it needs to move to a system that can now actively serve context. And this is the real shift that we are talking about, right? Let's give it a name, right? This has to evolve into a context serving layer, which is a system that lets agents query all your data as if they were one in real time. And it can replace any kind of federated querying that you need from your AI agents with a single system with governance attached that actually works. Not a pile of tool calls, but you just like hit the like a single endpoint, and then it has all of your data in open formats, governed, by open standards, served to you at very low latency and high QPS. So the system like this can make context queryable, fresh, and accessible at agent speed. The important thing is no longer theoretical, right? Recent advantages in storage formats, table abstractions, indexing have changed what lakehouses can do. And for the first time, the lakehouse is no longer a system of record. It can actually behave like a real-time system for agents, right? So it can support both narrow queries, wide queries. You can see in the benchmark, it can achieve lower latency than typical interactive queries while being faster than popular lakehouses on point lookups and doing joins, right? And all of this while achieving really good data freshness. So this changes what a role of a lakehouse can be for AI, right? Because the lakehouse already has unmatched kind of transformation efficiency, storage efficiency, right? So if we now combine that with serving speed, you get a pretty good system that can hold us and serve us well for the next decade for this AI era. So what's more is when more teams start to leverage this pattern, data engineers' role is going to see a massive increase in scope. Context engineering is what data engineering will become. And if you want to know more about this, I have a panel later on around the same topic. Tune in and love to see you there. So essentially, the context engineering again needs some context infrastructure with a lakehouse at its heart, like we talked about. It's not, again, I'm throwing words and terms here. It's not important point is not the label. Call it context infrastructure, context engineering, data serving for agents, the next lakehouse. The system requirement is the same, right? The whole stack now has to satisfy these constraints together. These are not new layers, but you need to have storage that can do store most of what you want. You need to attach semantics to be encoded alongside the data so that agents already know the meaning of all different pieces of data. They need to be able to retrieve it pretty quickly, as we looked at length, and kind of serve it at low latency, right? This is the architectural pressure the agent workload kind of now generates on top of your data platforms. If this feels like a big climb, just look around the conference. This stack rebuild that I'm talking about is already in motion, right? Across storage, tables, compute, and many different layers that you would see, right? So storage is evolving from just storing structured data to unstructured, semi-structured context. Tables are evolving from being collections of files to context containers, if you will. Compute is evolving from right, running pipelines to just having more AI collaboration, to building and operating pipelines. File formats, both bold and new, are becoming more capable at storing the kind of things that AI systems need, right? Like blob types, semi-structured data, efficient encoding of vectors, right? So catch these three talks later in the day, while they're all addressing different problems around storage for data on the Lakehouse, for the AI world. Tables are evolving too. Tables have been pretty fundamental abstraction for data platforms for decades. In this new world, table cannot be simply a grid of type values. It has to manage documents, images, embeddings, records, metadata, indexes, all of those things, right? So the role of a table has now become probably 10x. Your thin, kind of like a table formats, we just track some collection of files with some metadata, are no longer going to be like sufficient, right? So hoodies extending beyond structured records into unstructured data, embedding, building vector search inside tables is a part of this shift. We're still yearly, but it's part of the shift, right? So the goal here is to make the table itself capable of access patterns, serving the access patterns the agents need without bolting on another system downstream, right? So catch is exciting talk to go deeper if it's interesting to you. Once storage and tables evolve, compute has to evolve as well, right? So historically, engineers wrote ETLs, Spark jobs, by hand. You have to write and tune and optimize everything for the table by hand. This is changing. AI is already increasingly writing a lot of these pipelines, right? And where I think we'll go is to optimize and operate and troubleshoot these pipelines. This is not just code generation. This changes how engineers interact with compute systems, right? So if you're very curious into about what does the future of pipelines look like, we have a hands-on session for that. It's 25 minutes workshop where you can work with Quanton, which is a fast Spark engine. It's faster than every Spark engine out there, most Spark engines out there. And the idea with AI is very simple: bring AI assistance right into the Spark UI, right? So that it can like kind of be your co-pilot, debugging the Spark job and kind of like getting the pipeline right and kind of getting it optimized with the right context at runtime. Just if you want to try it, bring a laptop with Docker install. The two slots, so pick whichever works your schedule. Right? So stepping back a bit, all of this points to the same bigger architecture emerging right on top of the lake, which is file formats are evolving to store all kinds of data, any shape, any size. The table formats and the storage engines are adding indexing, vector search, any other similarity, ranking, even I think we need to go as far as autonomous table management and on these open formats to really make it super easy for people to build context and serve context. And the context serving layer, the low latency layer, which we discussed at length. And finally, pipelines are becoming AI generated, AI operated, and AI optimized. I think this is the new Lakehouse stack. And the takeaway is pretty simple. The last decade was about infrastructure for analytics, data science, machine learning, like for humans. The next decade is about same infrastructure for agents. That doesn't mean analytics goes away. That doesn't mean like we are going to vanish. That's not true. But I'm saying this is a new workload. Just like how we added data science on top of analytics on the same piece of data, we're now adding this as a new workload. Uh, autonomous software consuming context continuously, and this changes the nature of data platform. It's going to change the nature of data engineers and what their role looks like, right? So the data platforms used to just produce answers. Now they must continuously serve context to autonomous software. This is a big shift, right, for data and data lake ecosystem. agent infrastructure. Thank you for joining us today. Happy to chat more during the conference, and looks like we have a bunch of questions. So,
Dude, talk about a bunch of questions. Yes. So the probably the most upvoted, well, besides the one, is this being recorded? Which yes, it is. So that's nice. Second one is from Mark asking, why can't you set up an event-driven architecture for agents? This would allow agents to only focus on what it cares about, and the data schema can be built with a consistent context after you provide the schema, CP intent, there's probably a way to say that that I do not know, definition to the agent.
you could, and I think I do. That's a great question actually, and I do imagine a lot of agent um, thick, agents to be built this way. But let's also remember that having event-driven architectures doesn't fundamentally change the fact that you need also other pieces of context that are historical, and even for event-driven systems, you need like to do event replay and kind of like all of that, right? So what we talked about doesn't really replace that, but definitely it's a very reasonable way to build an agent as a event-driven system that is reacting and responding to events, right? And hitting a big context store like what we talked about, a serving layer to everything else.
Dude, awesome. All right. So I've got my own question that I'm going to selfishly ask. Forgive me,
Okay.
everyone, but ask a question in the Q&A section and then get up votes from people if you want me to ask it live. Should data be stored in a different way now for agents?
Yes, absolutely. Because like I mentioned, agents are so previously, right? If you have an analyst, you know what the kind of queries an analyst is going to write. They're typically nice to the warehouse, right? And the way the data is stored and laid out. Now agents can do arbitrary things based on what you ask them to do. So yeah, you need to fundamentally rethink how you lay out the data. Maybe you store multiple copies in different formats, or like index data a lot more. All of those are going to fundamentally change.
Nice. All right. Just as a reminder, I'm looking in the QA section, not the chat. I don't have my chat open. So if people are asking things in the chat, I'm not seeing it. Ask in the QA section. Most of the discussion around context engineering focuses on real time retrieval. Have you looked at the context construction phase itself, designing and organizing context ahead of time? Do you see advantages in that approach?
Uh, Absolutely, right. That is where I think this is a really good question as well. Right now, we're just scratching the surface. Even this talk focused a lot on the serving layer for the context, right? But if even going back to our workshop and everything, I think data pipelines are a big part of that context construction, and and they are also going to change in a fundamental way. For example, today ahead of time you need to build some fact dimension tables or something like that, some data modeling to serve data, right? But in the future, I think we'll have to have context, these data pipelines be dynamically generated as well. For example, if you notice an agent typically wants this kind of data, you may want to materialize that into a table using a pipeline. So I think that is how it's going to like kind of reverse, I think, the current flow. Today we humans query, like the analysts and data scientists query the data that you put out in data engineering. I think in the future you need to look at what context an agent actually needs, and then bake those contexts ahead of time using these pipelines, right? That is a shift that is going to happen. But we are yearly there. I think I see some teams starting to do it, but not as much as what the, the person who asked the question pointed to.
That awesome. There's a few more that I want to do as follow-ups to those, but I will also say that we're going to have a whole panel session, I think in a few hours that you're going to lead, you're coming back on here to talk to us
Right.
about context engineering is really just feature engineering and all that fun stuff. So stay tuned for that if you're out there and you really are enjoying the context engineering piece. The one that I know you can answer quickly, Vinoth, is does One House offer a community edition?
Oh, Yeah, so today we actually not the whole thing, but we announced something called quantum.dev. You can go to quantum.dev to just like try out our Spark engine. We'll be making rapid changes there, including the AI assist is going to be part of that community edition. We've not called it a community edition, but it's in spirit that is what we're doing.
Right. So it's Community Edition without the name Community Edition. There are some awesome questions that I'm reading through right now, so keep them coming, folks. Let's see this one. Why can't we store the context in agent MD or similar files? Why do we need storage for this? Is it the size of the context?
Yes, absolutely, right. It's so agent.md and these things can be like skills, for example, just using standard agent terminology. You can write skills and tell the agent how to go about doing its job, but fundamentally you need to connect it to tools, and tools just hit typically places where you need to pull context from, right? It's not practical to, for example, let's imagine a company like Walmart or like an Amazon. Like, how do you export all your orders into a .md file for an agent to know about them? Right? It's just not possible.
All right. This wouldn't be a real talk if we didn't have a security question. So thank you, Jyoti, for asking about that. What is the best approach for new data schemas to inherit security as new data is being produced by agents?
Interesting. So I'm not sure if I fully kind of distill that, but at a high level, for new data schemas to inherit security, meaning I think a lot of like agents should just like work with existing data catalogs and governance systems to generate these new schemas, right? That's what most people do today. That said, I do think the agents also increase the security and governance surface area a little bit more. This is a topic for another day, where I think you need to now also worry about what an agent can reason about with from the access that you're giving to data, not just verbatim what columns you're exposing, but also what a smart AI agent can automatically interpret, right? This was not a problem before. So those are the new challenges that I'm seeing, but the kind that should be solved by existing systems, I think.
I've got a few more for you, and they just keep coming, huh? So I love seeing this. The chat is uh, they're off the hook. Let's be honest. You all are asking questions that are
Nice.
really good. So next up, I've got why should we be focusing heavily on query performance since many projects just end up throwing compute at every problem?
um, because compute's very expensive. I would say, right? If you, for example, like I mentioned, right? Like so, the slides that I showed you on, let's say the point lookup query performance, where I compared against Databricks, right? We build a system that can achieve probably 1/4 of the latency. That means lower compute bills, right? But also it means your agent is now actually waiting less amount of time to return the result back to an user, right? So that I think is critical. So you can actually, yeah, you can throw compute at it, and it will scan the entire table or like do things like that. You can make it functionally work, but is that efficient? Is this going to give you the kind of the latency that you would expect from your for at the agent layer? That those are the real challenges to me. If you don't solve this, let's put two questions together, right? Somebody asked, why do you need context? Why can't this be in an MD file? So we established context has to be in a context store. It's like context is big, right? Now if you now marry that with I need fast responses from the agent, then you need to fundamentally solve this problem of how do I serve large amounts of context very, very fast, right? Otherwise your entire agent experience will be at risk.
And the other thing is certain workloads require very, very fast and other workloads don't, right? So if you're a voice agent, for example, you have to have super fast workloads. If it's a deep research agent, then people are a little more forgiving on that. So I think there's like looking at the workloads.
Yeah, there's a subtle point here. Let's say you're using, depending on whether you're using hosted models or self-hosting your own model. Let's say you're self-hosting your own model, then your GPU is basically your inference is stalled while it's waiting for tool output, right? So I mean, this actually wasted. Slowness wastes more money elsewhere for your
Yeah.
company, right? Maybe Anthropic or OpenAI would amortize that like somehow across the thing. I don't know what they're doing around it, right? But that fundamentally the point is you're stalling, like you're passing the agent's thinking while it's waiting for responses from a tool. That is a problem that we need to solve head on.
Yeah. All right. So here's a great one from Tiger. I'm not sure if that's how you say your name or pronounce your name, but if it's not, forgive me. As lakehouses evolve into agent infrastructure, what do you see as the minimum metadata provenance contract an AI agent should emit before its generated query job or action is trusted in production, especially for those scenarios where you need replayability, rollback, and audits?
Yeah. So to be honest, this is not my really my deep strong suit. I would look at things like Langfuse, other things where they're
Mm,
working on what maybe the agent is doing at inference or runtime. But from a prominent standpoint, I think, like I said, mostly this is now getting bolted on top of existing data catalogs. It hasn't broken in a very fundamental way yet. Not to say that it won't break, right? But I don't have
nice.
a deeper answer here.
Well, there's a ton more questions in the chat, and I know that you have a few minutes to hang out, so hopefully you can answer a
Yeah.
few of these in
Yes.
the Q&A section, typing them. We're gonna keep moving because I have one job today, and that one job is to keep us on time. So, in the meantime, I'm gonna send you off the stage. Give it up, everyone, for Vinoth. Thank you for coming. I really appreciate that keynote. I learned a ton, man.